Laws of chemical combination. The elements combine with each other and form compounds. This process is governed by 5 basic laws. Law of conservation of mass. The law states that the mass is neither created nor destroyed during chemical combination of matter. The law was first stated by Russian scientist Lomonosov in the year 1765. Later in 1783, French scientist Antoine Lavoisier also stated the same law independently. Lavoisier studied several combustion reactions. He determined masses of the reactants accurately before reactions and after the reaction. He also determined the masses of the products. He found that the masses of the reactants before reaction were in agreement with the total masses of products after completion of reaction. Consider burning of carbon. Carbon plus oxygen gives 2 carbon dioxide. According to law of conservation of mass, the sum of masses of carbon and oxygen, that is sum of masses of the reactants, is always equal to mass of product, carbon dioxide formed during the reaction. Law of definite composition. The law was stated by French chemist Joseph Proust. The law states that any pure compound always contain the same elements in a definite proportion, by weight irrespective of its source or method of a preparation. The law is also called law of definite proportions. In support of the law, it was experimentally proved that a naturally occurring pure sample of copper carbonate contains 51.35% copper by weight, 38.91% carbon by weight, and 9.74% oxygen by weight. Further, a pure sample of copper carbonate was synthesized in laboratory, and it was found that the percentage by weight of copper, carbon, and oxygen were exactly identical to that of sample of naturally occurring sample of copper carbonate. The law was further supported by different samples of pure water. It was observed that irrespective of sources of water, it contained 88.81% oxygen by weight and 11.19% hydrogen by weight. The different pure samples of sugar obtained 51.4% oxygen, 42.1% carbon, and 6.5% hydrogen by weight. French scientist Berthollet opposed the Proust's law of definite proportion by giving examples of the substances containing different proportions of elements. However, Berthollet's objections were ruled out, as the experimental work of analysis mentioned by Berthollet was found to be based on impure samples or incomplete reactions. Law of multiple proportions. The law was proposed by British scientist John Dalton, in 1803. The law states that, if two elements chemically combine with each other, forming two or more compounds with different compositions by weight, then the masses of two interacting elements in the two compounds are in the ratios of small whole numbers. For example, carbon reacts chemically with oxygen, forming two compounds, carbon monoxide and carbon dioxide. Carbon monoxide is poisonous combustible gas, while carbon dioxide is non-poisonous, non-combustible gas. On analysis, it was found that 1 gram of carbon reacts with 133 grams of oxygen to form carbon monoxide. And 1 gram of carbon reacts with 2.66 grams of oxygen to yield carbon dioxide. Hence, the ratios of weights of oxygen to that of carbon for two compounds are: for carbon dioxide is equal to 2.66 grams of oxygen upon 1.00 grams of carbon is equal to 2.66. For carbon monoxide is equal to 1.33 grams of oxygen upon 1.00 grams of carbon is equal to 1.33. The two ratio are in the proportion 2.66 upon 1.33 is equal to 2:1. Therefore, the ratio of masses of oxygen that combine with the same mass of carbon is 2:1. That is a simple ratio. Hydrogen interacts with oxygen to form two compounds, water and hydrogen peroxide. On analysis, it is found that water contains 88.89% by weight of oxygen and 11.11% by weight of hydrogen. Therefore, the ratio of percentage by weight of oxygen to that of hydrogen is equal to 88.89% by weight of oxygen upon 11.11% by weight of hydrogen is equal to 8 to 1. Similarly, hydrogen peroxide contains 94.12% by weight of oxygen and 5.88% by weight of hydrogen. Hence, the ratio of percentages by weights is equal to 94.12% by weight of oxygen upon 5.88% by weight of hydrogen is equal to 16. 16:1. Finally, the two ratios of the two compounds are in the proportion 16:1 upon 8:1 is equal to 2:1. Therefore, the ratio of weights of oxygen that combine with same weight of hydrogen is equal to 2:1. Gay-Lussac's law of combining volumes of gases. French chemist Joseph Louis Gay-Lussac studied number of gaseous reactions and discovered that there is a definite relationship between volumes of gaseous reactants and that of gaseous products. He generalized his observations and stated Gay-Lussac's law of combining volume as: when gases react together to produce gaseous products, the volumes of reactants and products bear a simple whole number ratio with each other, provided volumes are measured at same temperature and pressure. Illustrations. 1. Under identical conditions of temperature and pressure equal volumes, say 1 liter. That is 1 liter of each hydrogen and chlorine gases react together to produce double the volume, 2 liters of hydrogen chloride gas. That is, hydrogen plus chlorine gives 2 hydrogen chloride. 1 liter plus 1 liter gives 2 liters. 1 volume plus 1 volume gives 2 volume. Thus, the ratio of volumes is 1:1:2. 2. Under identical conditions of temperature and pressure, 2 liters of hydrogen gas react with 1 liter of oxygen gas to produce 2 liters of steam water vapor, that is, hydrogen plus oxygen gives 2 steam water vapor. 2 liters plus 1 liter gives 2 liters. 2 volume plus 1 volume gives 2 volume. The ratio of volumes is 2:1:2. 3. Under identical conditions of temperature and pressure, 1 liter of nitrogen gas reacts with 3 liters of hydrogen to produce 2 liters of ammonia gas, that is, nitrogen plus hydrogen gives 2 ammonia. 1 liter plus 3 liters gives 2 liters. 1 volume plus 3 volume, 2 volume. Here, the ratio of volumes is 1:3:2. All examples cited above indicate that, during gaseous reactions, gaseous reactants and products bear a simple ratio of whole numbers of volumes with each other. Volumes may be measured in any convenient unit like liter, milliliters, centimeter cube, decimeter cube, etc. For example, consider the reaction. Sulfur dioxide plus oxygen gives 2 sulfur trioxide. 200 milliliters plus 100 milliliters gives 200 milliliters. 1 volume plus 1/2 volume gives 1 volume. So that, the ratio of volumes is 2:1:2. Note that, the volumes are not additive. Though, in case of reaction between hydrogen and chlorine gases, it appears that volumes are additive. However, in case of hydrogen-oxygen reaction, 2 volumes of hydrogen and 1 volume of oxygen, equal to 3 volumes of reactants, get converted into 2 volumes of product steam. Similarly, in case of formation of ammonia, 1 volume of nitrogen reacts with 3 volumes of hydrogen, equal to 4 volumes, of reactants, get converted, into 2 volumes of product ammonia.